Coulomb's law. Coulomb's law states that the electrostatic force between two electric charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. If Q1 and Q2 are 2-point charges separated by a distance r, the electrostatic force F between the charges is given by F is directly proportional to Q1 Q2 by r square, or F is equal to K of modules of Q1 Q2 by r square, where K is a positive constant called Coulomb's constant. This value depends on the medium between the two charges. A. If the charges are in vacuum, then in SI units, K is equal to 1 by 4 pi epsilon naught, where epsilon naught is the permittivity of space. The value of epsilon naught is equal to 8.854 into 10 power minus 12 Coulomb square per Newton meter square, which was obtained by experiments. Thus K is equal to 8.988 into 10 power 9 Newton meter square per Coulomb square. Subtopics: Unit of charge, Coulomb. Vector form of Coulomb's law. Unit of charge, Coulomb. The unit of charge is Coulomb and is denoted by C. 1 coulomb of charge is that charge which, when placed 1 meter from another charge in vacuum, experiences an electrical force of repulsion of magnitude 9 into 10 power 9 newtons. B. If the charges are immersed in matter, then epsilon naught is replaced by EA, quantity characteristic of the matter involved. Then K is equal to 1 by 4 pi epsilon naught. The number epsilon naught is called absolute electric permittivity of the dielectric medium. In vacuum, epsilon is equal to epsilon naught, and the ratio epsilon r is equal to epsilon by epsilon naught is known as dielectric constant or relative permittivity. So Coulomb's law is written as F is equal to 1 by 4 pi epsilon naught Q1 Q2 by r square. Vector form of Coulomb's law. A. If Q1 Q2 greater than 0, that is either both Q1 and Q2 are positive or both are negative, then the charges repel each other. If Q1 Q2 less than 0, that is if the charges are dissimilar, then the charges attract each other. If F2, 1 is the force exerted on the charge Q2 by Q1 and Q1 Q2 greater than 0, then F2 1 bar is equal to K into Q1 Q2 by r square into R2 1 cap. When R2 1 cap is the unit vector pointing from Q2 to Q1, similarly, if F1 2 bar is the force exerted on charge Q2 by Q1 and Q1 Q2 greater than 0, then F1 2 bar is equal to K into Q1 Q2 by r square R1 2 cap, where R12 cap is the unit vector pointing from Q2 to Q1. But we know that R2 1 cap is equal to minus R1 2 cap. Therefore, F1 2 bar is equal to K into Q1 Q2 by r square of minus R2 1 cap is equal to minus K Q1 Q2 r square minus R2 1 cap is equal to minus F2 1 bar. That is, F1 2 bar is equal to minus F2 1 bar. Thus Coulomb's law agrees with Newton's third law.